Functional programming on .NET, the best of both worlds. Right. So that's me. My name's Isaac Abraham. I'm a consultant in the UK. I spent a few years in Germany, but I'm primarily from the UK. I run a consultancy called Compositional IT. We do F# consulting, .NET, Azure. I've basically been working in .NET since .NET 1.0. I don't even want to think about how long ago that was, but since the very beginning, since Visual Studio 7, I think it was. And I spent probably 10, 15 years in the C# world exclusively, and then I've moved on to F#, and I still sort of dabble a bit in C#. Before I sort of go too much further, I just want to get an idea of who I'm talking to, which will help me sort of understand where I should emphasize and not. So just a quick show of hands. How many here of you today are doing C# today? OK. Excellent. How many of you would say you're doing modern C#? And by that I mean C#, double digits, 10, 11, link. You're allowed to use var. You're allowed to use link. You know the drill. Is there anyone here doing F#? All right. That's the 12 of us in the whole world, right? And how many of you have got any experience in any functional language, whether it's Elm, Haskell, Scala, something like this? OK, good, good. OK, so what I really want to do today is to address like the why. Why should I be interested in functional programming? If anyone here saw Mads Torgerson's talk from like a week ago, it was on YouTube from NDC Sydney. That kind of, it's not going to hurt if you've watched that or if you watch that after this, but it's not going to be the same sort of content. But I really want to talk about what is FP really? What is it at its heart? How can we start to use it in C# if we wanted to? And should you even be trying to do functional programming today in C#? And what those limitations are. So I think there's quite a lot of misunderstanding about what is functional programming today, particularly in the .NET world. And I think it's led to functional programming having a kind of reputation as being hard. Maybe it's for maths and science. It's not for general purpose programming. Or at best, there's kind of a belief that, well, functional programming is cool. It's really interesting, but it's too hard to learn. Or it's ugly, there's loads of generic arguments, and why would I want to do this sort of thing in C#? And my aim today is to kind of dispel that and show you that actually you don't necessarily have to give up the good things about being productive, good tooling, .NET, but also let you benefit from functional programming techniques. What do I mean by like simple F# though, and functional programming, I guess? Has anyone seen this diagram before? It's like a journey that many of us have taken, I think, and I put myself in that category, where I started doing fairly simple code when I got out of uni. I didn't really know what I was doing. And then I got these books like Uncle Bob and Gang of Four and stuff like this on design patterns, and I sort of went crazy. And I started doing design patterns everywhere. And it got super complicated. And then I ended up going back to fairly simple code with just a few patterns and not much more. And I think when people think about F# and functional programming, we think of this bit in the middle here with things like applicatives and monads and category theory, all these things that no one really wants to do and gets scared of. And I want to sort of ignore all of that. Forget about all of that. Just think about simple things like functions, data, and types. Really not much more than that. So fairly simple concepts that you guys already know and how we can use those. There will be no talk about hard FP concepts today, none of that. So just the why, and I'm going to do this very briefly. And I'm talking from a perspective of having done functional programming for probably 10 years on .NET now. And it's pretty simple. Lower total cost of ownership, less bugs, happier developers, and improved time to market. It really is that simple, and it does work. But don't just take my word for it. Look at this phrase here. So when it comes to cloud programming, history is on the side of FP. I'm sorry, object-oriented programming is just not good for that. Simon Peyton-Jones, Eric Meyer, or Don Syme? Who said this? And that's right. It was actually Mads Torgersen, the C# program manager. So when I say this, this is not controversial. And if you look at the direction C# is going, it's getting more and more of these pseudo-functional features in the language. But why would he be saying that? What does he really mean when he says that? So I think it's worth just spending a few minutes talking about what actually functional programming is. And I think this is really the crux of it. We have all these sorts of terms that you may have heard of, lambda functions, extension methods, pattern matching, records. These are things that have come into C# in the last few versions. Lambdas have been there a bit longer. And then we've got other features that may be coming in the future, things like tagged unions, and maybe pure functions and curried functions. The truth is, in my opinion, none of that matters. None of these technologies or tools or terms actually really are about functional programming, really. Functional programming for humans is really just two things: expressions and immutability. And if you can get your head around those two, and they're really not hard, then you understand functional programming, and you can see how to use it in C# today. If you do those things and stick to these two rules, then you can start worrying about other things, like composition with functions and simple code and separation of data and behavior. But those kind of things come because of these two things on the left. So I'm just going to talk about what they are. Who here understands and says they're confident they know what an expression is in C#? Pretty much what I thought. And it's actually really simple. If you look on docs.microsoft.com, it's got this huge article that I didn't understand any of it when I looked at it last week. It's got things called expression statements and all sorts of crazy stuff. And I was like, I don't understand this. Let's find a simpler way of defining what expressions are. So this is all an expression is. Whenever you see that word expression, this is all it means. It's a block of code that you can assign to something. So ask yourself this question: can it be assigned? Is there a left-hand side of an equals? If it is, it's an expression. Congratulations. Oh. OK, we're on. So here are some examples. So add is a function. It takes in some data, and it's going to return you an answer. That's an expression. That's an expression, equality. It's got something assignable to the left-hand side. It's got a result. This is our friend the ternary operator. It also can be assigned to the left-hand side. Switch expressions, for those modern C# devs, you'll know what this is. Again, that's giving you a result on the left-hand side that's either yes or no. On the other hand, we've got statements. And essentially, anything that's not an expression, that doesn't fall into that category of can it be assigned to the left-hand side, that's what I would call a statement. So it's a block of code that has no result. So the sorts of things I'm thinking of are, does it return void? Does it have a result? Can you assign it? Or does it have some assignment in the middle of it? If it is, it's probably a statement. So add and print here. That's a statement, in effect, or a procedure. It's returning void. You can't assign it to anything. Console write line is also really a statement. Can't be assigned. It has no result. For each loops, switch case statements, if statements, they're all statements. They have no result. Why am I sort of making a point about these two things? It's because expressions are much, much easier to work with. You can understand them better. They're safer. You get less bugs when you use them. They're simpler to test. Usually, they're easier to reuse and compose together. So I would always say, like, this is a really core part of functional programming, is this idea of something goes in, you do some operation, and you get something back out. What you do with it is up to the caller. It's not about the implementation. And I've just put together a really simple example of it's a bit of a straw man, but hopefully you can see what I'm talking about here. So this is some code. that will basically take in a customer, and it's going to look at the status of the customer, their logged in state. And if they're logged in, we're going to set the name to Fred. Otherwise, we're going to set it to someone. And then at the very bottom, we're going to print out hello, Fred. But there are a couple of ways that this could go wrong. And this is really simple code. And you may look at it and think, I would never do this. But obviously, we have to start by assigning name to null. Now, if we were to remove this branch, this code would still compile. The compiler has no idea that you're doing something wrong. You've missed out a branch, and it will just happily go ahead and print hello null. Now, the compiler may warn you that you've got this potential unassignment, but it will still compile. It's still going to work fine. You could also do something like that and assign accidentally to the wrong variable. Again, the compiler has no idea what you're really trying to do is to guarantee I want to assign something to name. If you did this as an expression, that whole thing goes away. So I'm using a switch expression here. And here we've got this notion of like, if it's logged in, return Fred, otherwise return someone. But the result of that entire expression goes into name. So just by moving to this notion of expressions, we've removed these possible bugs and classes of bugs. And obviously, it's a very simple example here. But this idea of telling the compiler we want to do some logic and assign the result into something else is quite powerful. And if you use this everywhere, entire sort of issues that you face will just vanish in terms of accidentally assigning, refactoring, and so on. So that's kind of the first thing. The other one is immutability. Again, I looked on docsmicrosoft.com. I found one article about immutability that started talking about entity framework. So I skipped that out. This is all immutability means. Something can never change. You create some data, and its value is fixed for life. That's it. If you want to do a change, you make a copy of the data, and then the copy has the changes. So simple test, is all the data read-only? If it is, this thing is immutable. If it's not, it's not. So why would we want to do immutability? And it's the same sort of thing. Code is easier to reason about with immutability. You don't have to worry. For example, if you've got an object, you can give it to someone else, some other part of code. You don't have to worry about it changing behind your back. The value is fixed for life. You can decouple it much more easily because, for example, if data is immutable, you can probably make it public. And if it's public, you can probably write functions that deal with this data much more easily than you would if it's all encapsulated in a private class. Multi-threading definitely is a benefit because you have no shared mutable state, so you don't have locking or any sort of race conditions to worry about. You have data, anyone can read from it as often as you want. If anyone is worrying that what I'm talking about means your entire app has to be immutable, the answer is no. There will always be some mutable state in your application. The important thing is that it should be fairly closely scoped, small scope, and the exception to the rule, rather than what we have today where most data is mutable and you might have immutable data now and again. If anyone's seen these kind of architectures like hexagonal and onion, they all basically are talking about this. Mutable state on the edges of your app, and then immutable state in the middle. That's it. We're 15 minutes in, you've now learned functional programming. That is really all there is to it. Expressions, everything should have a result, and immutability. Everything is fixed for life. If you can follow those two simple rules, you're basically doing functional programming. The challenge is that those two things are actually somewhat difficult to do consistently in C#. I want to take a little step back now and just talk about what that might look like at a higher level in terms of how we compose code, how we build blocks together. So these are the sorts of things you will probably avoid if you're trying to do functional programming today, like class hierarchies, inheritance. That's basically out. Instead, you would probably look at static classes, static methods. Interfaces, maybe, but instead, you're going to prefer functions, just standalone functions that you plug together. Instead of stateful objects, pure functions, and this last one is actually quite important. You probably will move away from constructor injection and just have arguments into functions. That is it. There's no other way of sort of injecting state into a function. You just have normal function arguments. And that kind of leads to separation of behavior and data. So instead of having a class that has data in it and then methods that act on the data, we've got data on one side and functions on the other. And the functions take in some data and they return some other data. But they live independently, they operate independently. And this is really what Mads was talking about in his talk last year, with this idea of having data that's coming from some source and then the ability to abstract over it in many different ways. An example of how this might look. So this is a very simple calculator class, and I've written it in a kind of OOE style, should we say. So we've got some dependency injection here, because my calculator needs to log what it's doing. So I'm injecting an ilogger there, and I'm using the nice new simple constructor syntax in C#, which is very nice. And then down here, we're calling this logger.log method. So I've got this method on the type I'm calling. I've got some mutable state here, so I've got this value, and every time I call add, it's going to then mutate that state. So it's going to add whatever I've passed in and add it to the value. The thing that I don't like about this is the signature of add. It's kind of lying to us. It says, you give me a number, and I will give you back nothing. You can't see what it's doing behind the scenes. You need to look into the code to understand what it's doing. You don't know, just from looking at add, that it's calling logger. You have no idea that it's doing that either. So there's kind of a bit of magic going on here. What about testing? The same sort of thing. If we wanted to write a unit test for this function, you call this calculator, and you pass in a logger. You don't know where it's used. You call add, but then you assert on a different thing completely. You assert against value. It's like you have to know, I called add, but that's going to modify this value property. And it's like there's kind of action at a distance, shall we say. If I was to do this in a kind of a more functional style, this is what I would probably look for. So instead of having an instance class, this would just be static. There is only one calculator. We don't need many of them. There's no constructor anymore. That's gone. And all my dependencies, all my arguments, are going into the method directly. So I've got the logger being passed in, and I've got the state, the value, coming in, as well as the value I want to add to it. Also here, you'll notice that logger is no longer a type. It's not a class. It's just a function that I've passed in. It's just an action. This is kind of a bit like what we do with link when we're passing in functions. And instead of mutating, I just return the answer. It's up to the caller to decide what to do with it. I'm not interested. And the function signature now is actually much more honest. I can now see that I'm returning an integer, and these are the things that this function depends upon. There's no kind of magic there. Testing it is also much, much easier now. Yeah, I can explicitly see this is the log function that I depend on. I don't depend on just this entire logger type, and I know it's being called from within add because it's needed. And there's no internal state. I simply get back an answer, and I can assert that. So there's no magic going on or anything like that. And this kind of principle of simplicity of just I call something, I see what it needs, and I get back an answer, that's what we're really talking about here. So I want to come back now to all these other things we spoke about. Like I've not touched on any things like lambdas or records or tuples, and yet everyone is saying that like C# is functional now because it has these things. Like, how do those two things resolve? So if we Wonderful. Okay. We all good to carry on? There's no nuclear threat. Okay, so let's go back there. So, right. How do we resolve these things to what I've just been talking about for the last 20 minutes? So let's start with expressions and immutability at the bottom. Those are like fundamental pillars that I've just spoken about. Above that are things we want to do in an app. You know, defining types, reasoning about data, working with functions. And on top of that, we have all these nice features that C# has. Yeah, things like records and tuples, and pattern matching and lambdas. None of those are kind of fundamental to functional programming, really. All they are is syntactic sugar, most of them, that make your life easier to try and make use of these kind of things that I've shown you. Yeah, so instead of records and tuples, you could just use classes. But we all know that it's a pain to use classes to do like value objects, to do immutable data. That's what records are there to make life easier. But just because you're using records doesn't mean you're doing functional programming. Like, don't confuse the two. And I just want to focus on lambdas, particularly because everyone talks about lambda calculus and lambda expressions and functional blah, blah, blah. I just want to show you what I mean when I say that lambdas are not necessarily like a gateway to functional programming. This is a for loop that's going through some numbers and calling add and print. Is this bottom one more functional because I've changed it to use a lambda expression? No, it's exactly the same. Just because I happen to replace it with a lambda expression does not mean I'm doing functional programming now. It's exactly the same as the top one. The same way that if I'm using link, and I've got this select here, if I replace it with an anonymous method from C#2, does that mean this is less functional? To me, it's exactly the same code. It's just a slightly more complicated syntax. If I assign a lambda to a func and pass that in, it's exactly the same. And if I have a static method in a class, or even an instance method, it's no more or less functional. These are all exactly the same. Just because we're using a shorthand syntax doesn't make it functional programming. They are just syntactic sugar. They just make it easier to start working with functions. They don't do anything more than that. So just remember that. For those of you that are using link and that are allowed to use link, I just want to focus on why it is functional. Because if I was to ask, and I have done in the past, like, why is link functional? The first thing everyone says to me is lambda expressions. And the second thing they say is extension methods. But to be honest, that is, to my mind, those are not functional programming things as such. What's more important is that it's expression-oriented. Each of these stages in the pipeline is going to get some data, push it to another stage. That's going to get the data, push it to another stage. Yeah? These are all immutable collections. Yes, it's IEnumerable, but the idea is you've got one collection, that's then pushed into another one, which does a modification, which does another one. And each of these are independent from one another. You can change them, you can reorder them, nothing is going to break. We can compose functions together. So I've got select and I've got a square. And I can compose them to make a function called select squares. That's really what that's doing. And lastly, we've got this separation of data and behavior. So I've got numbers and then I've got my functions. But these functions don't live on numbers. They're not coupled to it. They're completely decoupled. Just as an exercise, I decided to see what would it look like if we had done link with objects instead of functions. And I'm just going to show you a couple of examples of what it might have been like. So for select, where we had our x goes to x before, you would probably need an interface, iSelectable. And if you wanted to do where, you would need an iFilterable interface. And then you'd probably have to implement each one of them every time you wanted. Is that me again? No? Okay. you'd probably have to do this every time you wanted another pipeline stage. You'd have to make a new class, implement this interface as a new type. And then you'd be passing them in everywhere. So we'd have select with a new square number operator and a new even number. So we're using things like decorator pattern and strategy pattern, and we've got parameterization via constructors again. It's all back to where we were, like in the C# 1 and 2 days. Let's go forward again. That's a good click. So just so you can see, like, that's the distinction that I'm getting at. It's not so much the lambda expressions that's important. So what would FP-lite look like? If we wanted to do FP in C# today, what sort of features would we be looking at? And this is really what I want to explore a little bit, is we would basically be focusing on, or I'm focusing on standard C# features. I don't want to use libraries like langx or one-of or things like that. Just what is out of the box in C# today? Let's just use simple rules. We're going to focus on this core set of functional programming, just expressions and immutable data. What would that look like? And to do this, I would say, let's take the approach that some other languages like F# take, which is let's split the language in two. And we're going to keep the bits of C# that are useful, and we're going to throw away the bits that are not useful for functional programming. And what's left, basically? So to me, what's not useful are things like mutable data, statements, inheritance, combining data and behavior, and like fire and forget. We want to get rid of all of that, and we want to focus on these things on the right. Yeah, immutability, expressions, composition, separation of data and behavior, and functions. Which really looks like this. You can't use instance classes anymore. You basically never use them. Void methods, not allowed. So you must always return something. Constructor parameters, out. Inheritance, out. Polymorphism, definitely out. So instead of that, you've got records for data, static methods for functions, function arguments, records for data, and pattern matching. That's basically how you would work together. The only type of inheritance you could use would be in very specific cases, where you want to show like a subtyping, but without any behavior. We'll come to whether or not I think that's a good thing or not to do, but this is what I would say, that if you wanted to do functional programming in C#, that's what it would probably look like. And if I was to go back to writing C# today, that was probably what I'd be doing. I probably wouldn't enjoy it very much. What is missing, though, from the language, and where might it be going next? Now, I can't speak for the C# team, but these are the sorts of things I would expect to see in the future. If C# is continuing down this journey of adding more functional features. So these would be things like union types. Has anyone heard of union types? Yeah, a few of you. OK, good. We'll go through a quick example of that. Probably exhaustive matching will come in as part of that, and maybe simpler composition. The things I think will be harder to get in C# will be immutability and expressions everywhere, because that basically is a breaking change. You can't break C#. So I think those two are probably off the table. And then curried functions, which is basically a way to compose and work with functions more easily, probably won't happen. And the same for this effect management. I don't think C# will get them. But let's focus on unions, because that one is probably coming in the next version of C#. So in OO today and in C#, you can do and very easily. You know, a customer has a name and an age and an address. And those are just fields. What you can't do very easily is model exclusion. A customer is this or this. They are credit-worthy or they are a credit risk. It's not so easy to do that kind of thing. Today, we would probably use inheritance for that. And that's really what unions are supposed to solve. So just to give you an example, let's say we had a customer we wanted to model in C#, and they've got a contact method. And the contact method is either email or post or telephone. But only one can be selected at any one time. And you need to be able to contact by them. So, I can either contact by email, contact by post, or contact by telephone. I've asked this question dozens of times, and every time, this is basically the answer I will end up with, which is, well, you put all the fields on your class. Yeah, the telephone number, the address, and the email address. And you set the ones to null that you're not using, and the ones that you are using, you fill in. And you can maybe do something like this. Like, if the telephone number is not null, then they must have the telephone number set. And we'll use that data. Or if the address line 1 isn't null, then that must mean we've got an address. Let's use that. Otherwise, it must be the email. Let's use that. Right? And then someone will say in the audience usually, oh, wait a minute, add an enum, because that will solve it. So we'll have an enum that specifies this is what I want. And then you can match over that and get the data. But it's basically the same thing. And if someone is accidentally sets the enum and forgets to set the data, then you'll get a null reference exception. And just in case anyone is thinking like, oh, wait, C# has got non-nullable reference types, that won't help you in this situation. You can't use it for mutual exclusion. So forget that. Let's skip that one out. This is the real way that you would do it in an object-oriented language, is you would use inheritance. So you would have a contact method abstract class, and then you'd inherit from it. So you'd have a telephone contact method, an address contact method, and an email method. And they'd have the data on it, and then you'd have a contact method on it as well. Who here would actually do that today? Like, anyone? Yeah, like one person's raised their hands, 2 people. Who here would actually have done something more like enums and if-then sort of thing? Yeah, a few people more. Switch case sort of thing? I mean, I'm not sure what other way there is really of doing this, apart from those 2 kind of ways. The way you can do it in C#, I think 10 onwards, is you can use pattern matching. So that's kind of the more modern way, where you would have a subclass, but rather than using polymorphism, you'd have a single method called contact, and then you'd switch over the contact method. And you'd try and safely unwrap it. So you'd safely cast it across. If it's telephone, then unwrap it and use the data. But I don't see many people doing this today. And that's just an example of like how this sort of thing, it's not clear how to do this sort of what should be fairly simple to do today, but in C# there's not a really good story for this yet, and that's the sort of thing that tag unions will solve. It will allow you to model mutual exclusion. A customer has this or this or this, and to safely deal with that data. Should you do what I've outlined today? We've still got 20 minutes, which is good. I can spend plenty of time. My gut feel is what I've showed you would probably be less than satisfying if you were to just stick to static methods, records, tuples, and a few other bits and pieces, because you're cutting away probably 60% of the language. You could start doing it, and your fellow colleagues on your team would come in and look at this and say, what have you done? Stop doing this. It's like completely unidiomatic C#. And it's just not what C# is designed for. More than that, the functional features are somewhat limited. I just want to show you again what Mads said, and he said this last week. So this is not controversial. C# is at its heart an OO language, and you're not going to get a full FP experience in C#. So you will get these nice language features like lambdas and pattern matching, but the fundamentals are never going to change. C# will always have this mutable state at its heart. And what we're really trying to do is go against the grain when we're trying to say, I want to do functional programming in C#. And there's a reason why that is. It's like the more times you add new language features, they have to integrate with every existing feature. And because C# has this mentality of we will not have any breaking changes ever, there's always a smaller space that new language features can fit into without going against any of the other ones. This isn't controversial, or shouldn't be. This doesn't mean that C# is bad, or that F# is better. is, but beside the point. What it just means is that you can't continually add features. It's not like, I like ice cream, I like cheese, I like chicken, and I like parsnips. But it doesn't mean that I can just throw them all into a big pot and I'm going to get something that's really tasty at the end of it. You can't just continually randomly add features because you'll end up with something like that. So you have to really think carefully, especially as some features in a language will actively work against other ones. So just as an example, I talked about things like curried functions before. You can't really do them in C#, the same way as type inference is somewhat limited, because you've got these features on the left that are really good features in C#. We love overloading, for example, and we like cyclical references, and we wouldn't want to lose them, but if you have them, you can't do something else. Or if you do, it's somewhat limited. So don't think of features in a language as just additive, but they have to work together, and each one of them is a trade-off with another one. So when I hear people talk about FP on C#, I think there are some good things about that. People are more excited about this idea of functional programming. And from an F# perspective, which is what I'm very passionate about, I like that because features like pattern matching, lambda functions, unions, those were considered somehow difficult a few years ago, but nowadays, records are pretty simple in C#, and people realize there's nothing to be scared of. So that's like the good side. The thing that I don't like is, or that I'm worried about, is people will try and do functional programming in C# and then say, oh, it's really ugly, I have generic arguments everywhere. Or it's really ugly, I have to put read-only, and I have to put private everywhere, and I have to change all the way I'm writing code, and static everywhere. Or that we say, well, I know functional programming because I'm using lambda functions. There's nothing more to learn. Believe me, that's a very superficial way of thinking about it. And the better way to look at it is there are other things to do. The same as Mads has said. Try a language that is functional first, and you'll see just how the defaults are very different. And I'll show you that in a minute. So just to finish off the kind of C# story here and functional programming, I would say, there are no shortcuts. If you want to do functional programming, those kind of things I've talked about, expressions and immutability, you can't skip them. You have to do them. Otherwise, you're sort of building on unsafe foundations, and there's no point doing it. C# will always be an OO first language. That's not a criticism. That's just what it's optimized for, and it's great at doing that. And it's got some extensions that kind of make it easier to do some kind of functional composition. But if you want to do these kind of basic things, I want to work with immutable data everywhere, and I want to use expressions everywhere, C# will never, it's not optimized for that because it was never designed from the start. So don't see that as a criticism of the language. It's simply the design choices of it. And the fact that you can't do everything in one language. So this is where I come to the fun bit, and I've got 20 minutes left to really talk about F#. So that's the other .NET language. If we forget about VB for the minute, it's a great language as well. But from an interesting point of view, it's basically C# with a slightly different syntax. Apologies for that, but that's how I see it. You really should try F# if you want to get a feel for what functional programming on .NET really would look like, or does look like. In the same way that C# is optimized for object-oriented programming with some functional extensions, you can flip that around and think of F# as a functional first language with object-oriented extensions. So if you like, for example, link, you like records, you like pattern matching, you tend to be writing simple functions that you pass around, that is what F# was designed for. And everything about the language is geared up towards that way of thinking. So if that's sort of thing you like, you should really try F# because you'll probably find it much more natural for what you want to do. The big difference is, whereas C# rather started with these core foundations of classes, mutability, inheritance in C#1, and then it's added in on top of that afterwards, these kind of other functional style features. F-sharp's always had this kind of two halves to the language. It's got a functional half and an object-oriented half, and the two don't really interact. If you want to do objects, go ahead, have fun. But if you want to do the functional side, then you have this very clean subset of the language that is just designed to do that really, really well. So, probably got slightly more than 60 seconds. I was going to do some coding in C#, but when I was practicing for this slide, for this talk, for the last 2 weeks, I realized that I've just lost it. I can't do C# anymore, and I was just fumbling everywhere. So that's why all the slides were pre-done. But I do know F# somewhat, so I'll be doing that instead. So I'm just using VS Code here. That visible for the back row? All good? Lovely, thank you. So I'm just going to give you an idea of the language. Now, what I'm using here is in VS Code is this thing called a REPL, which is F#. You can do console apps, class libraries, web apps, all of that. But it's also got this scripting mode where I can write code and just execute a few lines and get the results while I'm coding. So it's kind of like the immediate window when you're debugging C# apps, but while you're typing rather than running an application. So you can just explore things really quickly. So I can say things like let x equals 5, and then I can hit Alt-Enter, and you'll see at the bottom here, I get x equals 5. And then I could do something like x plus 10, and I get 15 at the bottom. But I can do this with, I can create types, I can create data, I can do all sorts of things, and start working nicely. So I just want to show you now the two things that I started on, which was immutability and expressions. So for example, in F#, if I say let x equals 5, you could sort of translate that to var x is 5, except in F#, you can't mutate. So if I try and change this value, it says this value is not mutable, and I've got to put in the word mutable here instead. And then I've actually got a mutable variable. This is like the opposite of C#, where by default, it's mutable, and if you want to make something immutable, you've got to use read-only or const, and there are certain ways to get around it. In F#, it's the opposite. Everything is const without you having to say it. In F#, everything's an expression. So by that I mean, even something like if-then. So if I was to say something like let y equals if, I don't know, system date time now hour equals 10, then hello Oslo, else, goodbye Oslo. So this is actually a branch of code that can actually have a result. So the result of this entire thing is assigned to y. So it's more like a switch expression. But in F#, that's like if is also an expression. So you don't have this notion of like a statement. Everything has a result. And if you even have a void method, in F#, that's not a void method. That actually returns an object that has no value in it. But you can still assign it to something. So everything has a result. In F#, we call it unit. And this notion of unit is actually getting quite popular now. And I see it in some C# libraries where people are designing their own type called unit to do exactly this sort of thing. So records in F# are very, very simple. For those of you that are using records in C# today, anyone? Yeah. I was having a look at them, and I like what they give you. What I don't like is there's kind of two ways of doing it, and that you have to have these like init and read-only and other keywords that are sort of needed, and they kind of make it a bit more, a bit less pleasurable, should we say, to use. F# records are super simple. Like, that is it. You just say, I want a type person. It's got a name and an age. And there's really not much more to it than that. If you want to create one, then you simply start assigning the fields. And if you just look where my mouse is there, you'll see that the compiler already knows that this is a type person. I don't even have to give it a type. The compiler's smart enough to see, well, you've given it name and age. There's a type above called name and age. It must be one of those. And if I miss out one, it will actually tell me, like, you've not given the field age, so please do it. So it's not dynamically typed, it's fully static, it's just really smart about inferring stuff. And of course, I get the usual sorts of equality. So these will be considered the same because they have the same value. Let's just define that. So person1 equals person2. In F# equals means equals. It doesn't mean assignment. So you don't need the double equals anywhere. OK, good. And if you want to do sort of mutation style stuff, you can say person with age equals 31. So the same sort of with syntax, except it's built into the language here rather than as kind of code-generated methods. OK. I want to show you briefly the calculator example that I showed you before, which was doing the adding with the logging, and just show you what that would look like in F# and how we can sort of make use of this kind of very simple function composition. And of course, yeah, I know this is a really arbitrary example of a calculator. I know that we're not spending our full-time jobs writing calculators. I get that. But if we remember, it had we were adding with a logger, and it had some state, and then it was the value we wanted to add. And we were doing like something like this. So we were saying logger, and that was a function that was adding value to state, and then we were returning it back out. Now in F#, you don't need to use the return keyword because everything is an expression, so we can just strip that out. We don't need curly braces because it's white space sensitive, so you just indent to get your scope, so you don't need to bother with curly brackets. And the compiler has basically figured out the types of all of these things for us. So if I mouse just above it, you'll see that it knows that state is an integer, value is an int, and we're returning an int. I could type them if I wanted to, like this, but that's not needed. The compiler is pretty smart and it figures things out. Oops, let's get rid of that. Now where it comes into a bit more power, and this is where things will be a bit foreign for looking at this from a C# perspective, is if I was to call this function, and I want to pass in my logger function. So here I'm just going to use console writeline. So I'm going to say system console writeline, and then I'm going to start with, let's actually invert these. So I'm saying that I want to use the writeline function as my logger. I want to add 10 to 0. And I can compile this, and then I can call it. And you can see at the bottom there I got adding 10 to 0. The answer is 10. Wonderful. What if I wanted to add another number to that? So I could either sort of bind that to something here. So I could say let x1 equals this, and then add that to x2. Or I could call it again. So I can say let's do this, and let's add 5 again. So that would be like the state for the second call. You know, this is the sort of thing we've seen in C# where you're chaining functions and you sort of have this expanding brackets. But it's kind of a bit ugly now. We're having to pass in system console writeline twice. If we'd have used object orientation, we would have passed that in as a dependency on the constructor. This isn't so nice. But F# lets us do the same kind of thing with functions. So I can say add with console. And then I've kind of built my own version of add, which just takes in the first argument, and the rest are still left standing, and I can still reuse them. So I've just kind of quickly composed the function, and I don't have to bother sort of doing that by hand. And then what I can then do is I can get rid of these parens, and I can invert them with this thing called a pipeline. So this says, take this value. Let me just get rid of this. Get the value of the first line and pipe it to the second one. And then I can get rid of my parens, and I can get rid of this. And now I've got this nice little DSL that I've built very, very easily, where I can say start with 0, add 10 to it, add 5 to it, and add 7 to it. And it just flows line by line. And I've not had to create extension methods. I've not had to do much in the way of like hard work. This is just like fundamental features in the language. So it lets me build functions very, very easily and compose them in different ways. Well, how much time we've got left? We'll skip this out. Let's just look at some domain modeling very briefly. So this is the example I touched on before with the contact methods. And this is probably what it would look like in F# and what it might look like in C# with some syntactic differences. So I wanted to have different contact methods, which is either email or telephone or post. And if it's email, I'm going to capture the address, which is over here. If it's telephone, then I want to capture the phone number, which is an integer. And if it's post, I want to capture the 3 lines of the address. And then I'm going to compose that with customer. So I'm going to say customer has a name and a contact method, which is either email or telephone or post. And you can just continually plug these things together. And, or this, or that, and this, or that. We can create a record very easily, and then we can use pattern matching to match on top of this field. So I've got here a function called contact, which takes in a customer, and I'm switching on contact and saying, if it's an email, I'm going to send them an email. If it's a phone number, I'm going to call them. And of course, if I comment out a line there, then I'm going to get a warning that says, oh, you haven't handled the post condition. Please remember to handle that. If I was to put in an arbitrary email address there, then I'm going to get a warning, I haven't handled another email address. Please handle all the cases. And it will continually go through and make sure that I've handled every conceivable potential case of emails, telephones, and contact methods. Okay, jolly good. I think we're nearly done. Let's have a look. DVD. Yeah, the calculator I've already done. Okay, good. Yeah, fine. I haven't shown you everything in 60 seconds there, clearly, in F#, but take it from me when I say you can do all the normal things, like you have the full .NET framework, or the BCL. You can use everything from there. You can use ASP.NET Core. There are lovely web frameworks you can use on top of ASP.NET Core. You can also do F# in the browser. There's a project that lets you transpile F# into JavaScript. So we're using that to do full-stack web apps entirely in F# called SafeStack. You can have a look at that. But that's basically enough to hopefully get you interested in just exploring it and just seeing. You can open up VS Code, you download one extension called Ionide, and you're good to go. So just to wrap up, we've got 5 minutes left, which is fine. 1, is C# a functional programming language? I would say no. It's an object-oriented language with some functional extensions. How do I feel about the FP languages in C#? I think they're good to let you put your toe in the water to get a feel for it. But please don't think that if you find the experience suboptimal in C#, if you find it's a bit clunky when you're trying to do things like I've described, that means that FP is clunky. It's more the fact that it's not what C# was designed for. So should you try it? Yes, but don't expect a perfect experience. Like, take Mad's word for it, don't take mine for it. Try a language, ideally on .NET, because you know the framework already. It's not hard. File new project in Visual Studio or Rider. .NET CLI, .NET New. You have all the standard templates in F# as well. So yes, I would certainly try it. You can also do mixed language solutions, so you could do C# and F#. F# has a really good interop story. So you can write F# functions, and they just look like methods to C#. Records just look like classes to C#. Yeah, let's leave it as that. So I will just wrap up to say thank you very much. You can get me on Twitter. Isaac Abraham. You can contact me on our company email address, info@compositionalit. We are hiring. We don't need F# experienced devs. We don't even need .NET devs. We do provide visa sponsorship if you're interested. My book has just been released, finally. It took a bit longer than I thought. If you're interested, I do have some free codes to the book, so if you want to try it out, you can literally get started for free. Just hit me up after this talk, and I'll send you a code. So thank you very much. We do have 4 minutes. If you want any questions, just come over and we can chat. Thank you.